Next concept which you are going to see is increasing and decreasing function. It is a very important concept in calculus. The concept remains very easy. It is something which you can say it intuitively. Okay. See here, I drawn a function f of x with respect to x in the x in the horizontal axis, and y is a function of x in y axis, in a vertical axis, and here x in a horizontal axis and y is a function of x in vertical axis, right? So if you see this function, if I move from left side to right side, okay, if I move from left side to right side, I am fixing a first point. That first point is x1. I can take this first point anywhere, wherever I want. I could take here also 1 or here also 1. First point which I am going to take in this curve of the function is x1. Okay, I taken the first point here, x1. Now I am keep on moving, and if I take any point after x1, if I take a point here and if I mark it as 2, this will be x2, right? And what observation you could make here, always whatever point which I am going to take after 1, moving towards right, whatever point I am going to take which is after 1, that point will be surely greater than that of x, right? That is what I written here. x1 is less than that of x2. So I taken a point here x2 and x1. If I consider a point in this function, this f of x is represented as this curve, right? The function f of x is represented as this curve. So I taken a point x1, I taken a point x2 here. So we know that x1 is less than that of x2. Simple. x1 is less than that of x2. And what about functions of that? Functions of x1 is f of x1. Function of x2 is f of x2. And from the graph it is very clear that f of x2 is greater than that of f of x1. If I choose a point here, if I choose x2 here, f of x2 is greater than that of f of x1. But is that right every time? Is that right every time for any 2 points? Is that right? It is not, right? It is not going to be right every time. For example, instead of choosing a point here, if I choose a point here, let this be x2. What will happen to my f of x2? F of x1 is also f of x1 and f of x2, both will lie the same because they are straight line, right? So if I take a point here that has x2, then of course f of x2 is going to be greater than that of f of x1. Clear, right? It is clear. So now what does it mean by increasing function? If I move towards right, or in the other sense, if I increase x value, then my f of x value should also increase. If f of x value also increases, then it is increasing function. See here, from this point, let me mark it as A, B, C. If I move from A to B, my x value is increasing. But my f of x value is remaining constant. It is not increasing, right? But from A to C, that is from after crossing the B, the values are getting increasing. So if this is the case, then we will say the function is increasing. So it is confusing, right? Why the function is increasing still between A and B? Still between A and B it is a constant, but why I am saying it is increasing, that is the terminology which we are following. Even though my f of x1 is less than, strictly speaking f of x1 should be less than f of x2, then only it is increasing. But we are going to consider f of x1 lesser than or equal to f of x2 as also increasing function. Why is the reason? What is the reason for that? See here, this function, wherever I take a point, wherever I take 2 point, x1, even if I take a point x2 here, my f of x2 will be surely greater than that of f of x1. Even if I take a point here, or even if I take a point here or here, wherever I take, my f of x2 is going to be greater than that of f of x1, which means as x increases, as I am going towards right hand side, my f of x value is also getting increased. Strictly speaking, this is increasing function. This is not increasing function because in between A and B it is not increasing, right? In between A and B, f of x is remaining constant. From O to A, the function is increasing. As x increases, the function is getting increased. From B to C, As x increases, function is getting increased, but a to b the function is not getting increased, it is remaining constant, but still we are calling it increasing. But strictly speaking, this is increasing function, because as x increases everywhere, as x increasing, f of x is keep on getting increased. So that is the reason why we call this type of function as strictly increasing function. Strictly increasing function. What is the meaning? Simply, increasing function means there can be a constant line in between. There can be, the curve can become constant and then it can increase. But strictly increasing means the curve will be always increasing. That is, as x value keep on increase, y value will be keep on increasing. So that is the difference between increasing and decreasing function. First for now understand the difference, then we will go how to find this mathematically. Simply, if x1 is less than x2, if f of x1 is lesser than or equal to f of x2, then we will call it as increasing function, right? Because it can be equal to also. If I take a point in between a and b, then f of x1 and f of x2 will be same. If I take a point between b and c, then f of x1 and f of x2 is not same. F of x1 is less than that of f of x2. Clear? So now, but in that case, wherever I take the point, f of x1 is surely going to be less than that of f of x2. Simply, as we move from left to right, that is, as we increase x value, here there is possibility for constant value and then increase, or increase then becoming constant, it is possible. But in strictly increasing function, as we increase x, f of x will be keep on increasing. So it is the difference. Now we will go for decreasing function. See here, there is a two curve which I drawn. So let me take a point. Let me take a point x1 and let me take a point x2. If I take a point x2 here, what is happening? As x is getting increased and we are very sure that x1 is going to be less than that of x2, right? Because x2 is lying after that. So x1 is going to be less than that of x2. And what about f of x1 and f of x2? F of x1 is also this point, f of x2 is also this point. So both f of x1 and f of x2 is same, right? But if I take x2 here, what will happen? See, what is happening to my f of x2? What is happening to my f of x2? My f of x2 is decreasing. Initially my f of x1 was here, and now as I keep on increasing my x value, my f of x value is decreasing. So it is a decreasing function. And the same thing, strictly speaking, this is a constant, right? Strictly speaking, it is a constant function. But as per the terminology, if f of x1 is greater than or equal to f of x2, we will call it as decreasing function. As x1 is less than x2, x1 is going to lie before x2, but f of x1 will be greater than or equal to f of x2. You can feel that. In this case, f of x1 is here, but in this case, f of x2 is here. If I take x2 at this point, then f of x1 and f of x2 are in the same line. So it is a decreasing function. Again, the same thing, strictly speaking, it is not right. So which one will be right? Now see here. x1, x2 corresponding to x1, this will be my f of x1, and corresponding to x2, this will be my f of x2. So we can see it here easily. As x value increases, my function value getting decreased. And wherever I take x2 point, my f of x value will be keep on decreasing. So in this case, we are sure that x1 is, in this case we are sure that x1 is less than x2. So, and we are also very sure that f of x1 will be always greater than f of x2. If this condition is satisfied, then we will call it as strictly decreasing function. It is strictly decreasing. So it is the difference between increasing function, strictly increasing function, decreasing function, strictly decreasing function. If it is a increasing function, there can be constant line, then it can get increased. If it is a decreasing function, there can be constant line, then the value will get decreased. If it is strictly increasing, always the value will be getting increasing. If it is strictly decreasing, always the value will be getting decreasing. That is, f of x value will be decreasing as x value increases. So this is a conceptual part, what is actually means by geometrically we seen, and how we can find it by using a slope concept, that we will see now. I drawn a two function here. One function is increasing as x value increases, y value, that is f of x value, is keep on getting increased. Here it is a decreasing function, the red colored one, as x value increases, the y value is keep on decreasing, or other sense f of x value is keep on decreasing, right? So what I did, I taken a point P in the curve, and I drawn a tangent to it. And I taken a point P here and I drawn a tangent to it. What is happening? When it is intersecting x-axis, the angle made with respect to positive x-axis is theta, and we are very sure that theta here is what? Acute. Right? Acute angle which is less than 90 degree. We are very sure about that. What about this? The angle which is made with positive x-axis, it is positive x-axis, and the angle made with the positive x-axis for the tangent is beta, right? So on beta is obtuse, that is, it is going to be greater than 90 degree. And what is slope? How to find the slope of the tangent? One is to find differentiation about this point, right? If I want to find differentiation about this point, let me fix this point to be some x. It is some x, right? A point P will have some x value, right? So differentiation about this point, which is nothing but dy by dx at point P, or on the other sense I could directly write f dash of x, right? F dash of x will be nothing but my slope of the curve. Slope of the curve is nothing but differentiation with respect to x, differentiation with respect to horizontal axis. So which is f dash of x. And what about this f dash of x? What is the other formula which you have for slope? Which is nothing but tan of this angle, tan of the angle which is made. So tan theta, and tan theta, if the angle is acute, surely tan theta is going to be positive. You might know the curve. If you don't know the curve, just go back to the basic video lecture which I made, how tan theta will vary, then you will get to know. If the angle is acute, then surely tan theta will be positive, which means it will be greater than 1. It will be greater than 0. It will be greater than 0. So what is the condition? It is a strictly increasing function, so f dash of x has to be greater than 0, which is nothing but slope of the curves. If the slope of the curve is greater than 0, then the function is strictly increasing. What about increasing? It should be equal to, that is f dash of x should be greater than or equal to 0. Simple. Now come for this. What is happening? Beta is negative, that is the angle with respect to x-axis is beta. Angle of this tangent with respect to x-axis is beta. And how to find slope? Slope remains same. If you want to find slope, I need to differentiate this y with respect to x, which will be equal to tan of beta. So what about tan of beta? Beta is obtuse angle. Again, go back to the curve which we discussed in the basic video lecture. Beta is obtuse angle, so surely it is going to be negative, which means it will be less than 0. So what is the condition for strictly decreasing function? It should be less than 0. So this is what we got. Simple thing. In increasing function, slope will be greater than 0. In a strictly increasing function, slope will be greater than 0. In a strictly decreasing function, slope will be less than 0. So now we will go for next case. Not a next case. We will discuss about, we seen strictly increasing and strictly decreasing, and then I will give you the remaining case, increasing and decreasing function too. See, we have, if f dash of x is greater than 0, it is strictly increasing function, and if f dash of x is equal to 0 means what? The line is going to be straight, which is neither increasing nor decreasing. And finally, what about f dash of x is less than 0? It is strictly decreasing. So I hope this would have cleared your concept on increasing and decreasing function. We will do one or two problems on this. Then we have a problem here in increasing function and decreasing function. You could see f of x equal to e power x by 1 plus e power x, and x increases from minus infinity to infinity. That is what they are giving. If x increases from minus infinity to infinity, then what will be my f of x? Either it is increasing monotonically in the sense it is not decreasing or it is not increasing. It is increasing continuously, that is monotonically. Monotonically decreases means monotonically it is decreasing. Or it is increases to maximum, which means it is increasing to some value and then it is decreasing. This, or it is increasing or it is decreasing, or decreases to a maximum value, it decreases to a minimum value and then it is increases. This is what they are asking, right? So we see in a concept of maxima and minima. In that concept I said, and also in the concept of increasing and decreasing function also, what will happen? If f dash of x is greater than 0, which is positive, then it is increasing function. The value will increase, right? If f dash of x is lesser than 0, it is decreasing function, that is the function will get decreased. What about f dash of x equal to 0? It is neither increasing nor decreasing, which means the curve will be straight, or there is another possibility. What is that possibility? F dash of x is equal to 0 means what? Slope is becoming 0. There is a possibility that the curve could increase and it will reach some value and then it will decrease. Even now if I draw a tangent at this point, okay, if I am drawing a tangent at this point, the tangent is parallel to x axis, which is nothing but the slope is 0. That is f dash of x is 0. F dash of x at this point is 0. So that is the maximum value. When it reaches maximum value, at that point the f dash of x is becoming 0. Same applicable for this also. It is decreasing and then it is increasing, and when it reaches minimum value, and if I draw a straight line, the slope value is 0, which is nothing but f dash of x is 0. So if f dash of x becomes 0, there is two possibility. One possibility is either the function will increase and then it will become constant and then it will decrease. That is possibility is there. Another possibility is the function will decrease, the function will become constant and then function will be increasing. At this area, f dash of x is 0. At this point, f dash of x is 0. This is possible. That is there will be straight line and then it will increase. That is the x value will become, f of x value will become constant and then it will increase or it will decrease, or else it will reach some position and then again it will start to decrease. That is also possible. So this one we covered in maxima and minima. This one we covered in increasing and decreasing function. So now what all this thing related to our question? What is the concept which is related to our question? You could see they are giving that either it is increasing monotonically. First option is what they are asking. It is increasing monotonically, or it is decreasing monotonically, or it is increasing to maximum value and then it is decreasing, or it is decreasing to minimum value and then it is increasing. That is the question here, right? So if you find one value, we can easily judge what is the answer is. What is that value? Nothing but f dash of x. Simple. Simply if I find f dash of x and if f dash of x is greater than 0, then surely the function will be monotonically increases. If f dash of x is less than 0, then surely the function is monotonically decreases. If f dash of x is equal to 0, then there are many possibilities. What are all the possibilities? Either it could increase and decrease, or it could decrease and increase, or it could increase and become constant and decrease, or it could decrease and become constant and increase. All possibilities are there. We will discuss another problem. In that problem, this confusion will get cleared off. For this problem, first we will focus on f dash of x. First we will find f dash of x. Then we will clear this. Then we will clear the concept. So first, what is f dash of x? My f of x is e to the power of x by 1 plus e to the power of x. So now if I differentiate this, it is u by v method. So u by v method it will be 1 plus ex whole square. V square should be in the denominator, and v multiplied by u dash minus of u multiplied by v dash. If I differentiate v, 1 will become 0, e will become e power x. Now what is happening here? 1 plus, so if I rearrange it, what will happen? 1 into e power x plus e power x into e power x, it will be e power 2x minus e power x into e power x, it's going to be e power 2x. So this and this will get cancelled off. So by 1 plus e to the power of x whole square. So this is my f dash of x. Now what we need to do? We are not very sure that whether it is whether the function f dash of x is becoming 0 or not, right? It will be equal to e power x by 1 plus e power x whole square. What can we do? The concept from our maxima and minima. We can equate this to 0 and we will find one value for x, and if that x value is lying between, if we find some x value, then surely, and that if that x value is lying between minus infinity and infinity, then we can surely say that there will be a critical point, which means there is possibility for slope becoming 0, right? So now equating it to 0, what happens? E to the power of x should be equal to 0, which means x will be equal to minus infinity. We know that when x becomes minus infinity, then only e to the power of minus infinity will become 0. I drawn the curve and I explained to you exponential value as x approaches, as x tending to minus infinity, my y value will become 0, which is nothing but my e power x value will become 0. As x is tending to minus infinity, e power x will become 0. Just go back to the exponential and logarithmic video. In that video I explained it very clearly. So now e power minus infinity will be 0, so x is equal to minus infinity. So from this what we can say? Very simple. We have only one critical point. That critical point is x is equal to minus infinity, right? That is clear. So which means if there is a curve, then critical point is at minus infinity. So after this critical point, the function is not going to become, that is the f dash of x is not going to become 0 again. So there is only one possibility, either it should decrease or it should increase continuously. That is the only possible, because there is no other critical point in between. If there is any other critical point in between, then there is possibility for increasing, then there is possibility for decreasing until that point and increasing, or increasing at that point and then decreasing. But there is no critical point except x equal to minus infinity. So which means it is very clear that it should be either increase monotonically or decrease monotonically. These two options are not going to be right. How to find whether it is increasing or decreasing? Now we can apply it very simply. Take any 2 points, or simply you can substitute minus infinity and infinity itself in f of x. F of minus infinity will be, or that is also not needed. What we could do, we are very sure that f of minus infinity, in f of minus infinity it is going to have some value, right? So we can take some value between minus infinity to infinity. For example, let me take minus 2 and 0. It is x1, it is x2. So if x1 is less than x2 and if f of x1 is also less than f of x2, then we can say the function is increasing, right? And if x1 is less than x2 and if f of x1 is greater than f of x2, then we can say the function is decreasing. So now we will check what will be my f of minus 2. So if I substitute minus 2 here, it will be e to the power of minus 2 by 1 plus e to the power of minus 2, right? And what about f of 0? Substituting 0 there, e to the power of 0 is 1 and e to the power of 0 is 1, again it's going to be 1. So what we can judge from this, you don't have to substitute the value, and if you have a calculator you can substitute and check it out. E to the power of 2 into 1 plus e to the power of minus 2, and what we can judge from this, it's very simple to judge, right? Surely one denominator a positive value and 1 plus some value, and it should be positive, right? So the denominator is positive, 1 plus positive value, surely the value will be less than 1. 1 divided by some positive value, so surely the value is going to be less than 1. That is for sure. I don't want the value, If you have a calculator, you just calculate the value, you will get some value in 0.56 or 0.65, some decimal value. So now what we can judge? x1 is less than x2 and f of x1 is some decimal value which is less than 1 and f of x2 is 1, which means f of x1 is lesser than f of x2, which means it is increasing. And it is increasing, and also it is strictly increasing or monotonically increases. The reason is there is only one critical point, and one critical point lies in minus infinity. So how it is going to vary? You can see, you can check it. You can show it somewhat. It's like at minus infinity it will be having some value at corresponding to minus infinity. I'm just showing hypothetically. I cannot show minus infinity exactly in the figure. Minus infinity, and after this it will be keep on increases. That is the figure, because there is only one critical point in between minus infinity and infinity. There is no other critical point, and from the definition we found that if x1 is less than x2, then f of x1 is less than f of x2. So obviously after this point the function is going to increase continuously. So the answer is monotonically increases. So if you understood the concept of maxima minima and increasing decreasing function clearly, then this problem is very simple, but still it is a very good problem.